look at a slightly longer and slightly more difficult question on ultrasound. Pause the video now and try parts A and B. So a frequency of 20 megahertz. So frequency is the number of waves per second, or number of complete waves per second. And 20 megahertz, well, mega means a million, or 1 times 10 to the 6. So 20 megahertz means 20 million waves per second. So this bit here you wouldn't need to put. This is the full answer. State 2 things that happen to the ultrasound waves during a scan that allow an image to be formed. So the waves are emitted from the transducer. They are reflected off the fetus, and they are detected by the transducer. So they're emitted, they travel through the body, they transmit through the body, they reflect off the fetus, they come back up to the transducer, detected, and then a computer can create an image. Part C, slightly trickier question. Pause the video now and try this question. So a low frequency means there are fewer waves per second, fewer oscillations per second. So what this means is a lower energy wave. And a lower energy wave is good because there is less chance of harm to the baby. If you have a really high frequency ultrasound wave, because the wave is oscillating so many times each second, it can actually cause some heating, or it could cause some other damage. One use of ultrasound is also to break up kidney stones, and obviously we don't want to do any kind of damage like that to a baby, so you would use a slightly lower frequency. Okay, final 2 parts of the question. Pause the video now and try both of these parts of the question. So in part I, we have our transducer, we have the waves traveling to the baby or the fetus, and then they are reflected and travel back. So what we can use is we can use the relationship speed is distance over time. We can rearrange this. Speed times time is distance over speed, and this is how we can work out the time that the waves take to go there and back. So the distance is not this. Firstly, we want to convert it to meters, which is 0.04 meters divided by 100. And we also need to recognize that the waves are going there and they're going back before they are detected again. So the distance is 0.04 meters times by 2, and the speed is 1,540 meters per second. So the time is 5.2 times 10 to the minus 5 seconds. Or if you wanted to give that in a slightly different way, you could say it's 52 microseconds. But this is perfectly fine because actually the units here are seconds. How many wavelengths are contained in the distance between the probe and the nearest part of the fetus? So how many waves can we fit in 4 centimeters? Well, obviously we would need to work out the wavelength. So we should recall this relationship. The speed of a wave is the frequency times by the wavelength. So the wavelength is the speed divided by the frequency. So 1,540 divided by 20 megahertz. And we've already in part A said what this means, 20 million. So 20 times 10 to the 6. So that gives us 7.7 times 10 to the minus 5 meters for the wavelength. and we want to figure out how many we can fit in 0.04 meters. So 0.04 meters divided by our wavelength, 7.7 times 10 to the minus 5 meters, gives us 519 wavelength.